Hey there, Dangar here. Today's video is on trim tilt relays. I'm hoping this video will give you all the knowledge you need to diagnose and fix any problems you might be having with a trim tilt relay, but I'm also going to go through how to build a trim tilt relay from scratch using cheap parts from an auto store. My motivation for doing this video was being asked by a viewer if they could just add a switch to somewhere near the transom of the boat to control the trim tilt on their outboard because it didn't have a relay in it. And I guess the answer is yes, you can, but hopefully when we start going through this you'll see why it's much better to use these types of relays, particularly given the sort of current draw you do get from trim tilt motors. I'm going to start this video by going over to the blackboard and showing a bit of the theory. I know the dreaded blackboard and theory, but the backbone of this video will be making this working trim tilt relay, so hopefully it won't be too theoretical. So this is a trim tilt relay from a Mercury outboard. As you can see, they're pretty small things. They generally have 4 or 5 pins, these automotive style relays, and the purpose of them is to switch a current on and off. That's what they do. I've drawn here a little diagram that I hope helps explain how the relay and the motor work together. The basic bits we've got here is everything inside this white box is the relay itself. This is the motor, so it has 2 wires in. Generally there are blue and a green wire, you'll see here. So that's our motor with the 2 wires in, that's here. This is our 12-volt battery, and up here is a switch that might be up at the helm in the boat. So the idea with a relay is that positive from the battery comes to one side of the switch. Then when you close that switch, power can flow through the relay and then back to the negative side of the battery. So by closing this switch, switching it on, you're activating the relay. The relay here has a little electromagnet inside it, and when this electromagnet comes on, it pulls this little switch closed, and that means that power can then run from the battery here through this switch that's now been closed, through the motor to make it run, and back to the negative side of the battery. So all a relay is a switch that activates another switch, the relay, to turn something on. And the reason we do that, the reason we don't have our motor connected to our battery with just a switch in line, is because this wire is quite thin, can travel a long distance, but only takes a very low current, a small amount of electricity. Whereas this wire generally is quite short. This relay's at the back of the boat, the battery's at the back of the boat, the motor's at the back of the boat. So there's a heavy gauge wire running a short distance, and it can carry the high current that your motor needs to run. So with this circuit, we can turn a device on and off. And this is very similar to perhaps the circuit you might have for a starter motor. A starter motor only spins in one direction. You turn the key ignition, and that's what that switch is, it's the key at the helm. It activates the starter relay or the starter solenoid. The solenoid activates, pulls this shut, and a really high current can flow through the starter motor. So that's the basic idea of what a relay does, and that's exactly how it would work for a single direction motor like a starter motor. Now, in order to make current flow in both directions, which is what enables your starter motor to turn in 2 different directions and as a result allow your trim tilt to go up and down, you need to use 2 relays. Often in an outboard you'll see the trim tilt relay is actually 1 unit. Even though the diagram I'm about to show you has 2 relays, Mercury, for example, does actually physically have 2 separate relays, and it goes to a loom with a set of wires like this. These inputs and outputs from these 2 relays are identical to the ones on a single bespoke trim tilt relay that, say, a Yamaha or even a Honda I think might have. But the thing I really like about this design is that it gives you a bit more of a clue how it actually works, and you can replace the 2 relays independently. You don't have to go and buy a whole new unit. So I kind of like the way Mercury does this. And this system's also the easiest one to do if you're building it yourself, because it fundamentally uses off-the-shelf parts. What I'm going to do now is erase some of this diagram, add in the second relay on the other side, and then show you how this combination of 2 relays can be used to reverse the polarity, to allow the current to flow in a different direction and allow the motor to spin in 2 different directions. Don't freak out, it's not as bad as it looks. Things are slightly rearranged though, so I'll give you the heads up again. So now we've got the battery in the middle just because it's easier to sort of show where the wires go. This is still the motor. The motor has these blue and green wires, so there's the blue and green here. And instead of one relay, we've now got one relay on each side. Obviously, those relays don't need to be positioned in any particular way, it's just for the diagram. In this case, with these Mariner or Mercury ones, the relays are literally just side by side. It's only the wires that run them to the places they need to go. So, here's the deal. We now have a switch that has 3 positions. The switch is connected to battery ground here, and eventually will come through here to battery positive. So that once again is that complete circuit. These magnets inside relays, it doesn't matter which way the current flows through them. So we could have positive coming into our switch, and then we could have the electricity come through this magnet and go to negative on our battery. As long as it's a complete circuit, that's all that matters. Okay, but in this case, I've got the switch hooked up to negative and the relay hooked up to positive. So what this means is that when this switch is in this off position, which is the same as your trim tool switch, so here's the original one from the Mercury. This switch has down, up, but its third position is actually this neutral position where it's off. So it's got 3 pins in the bottom there, you can see, and this is our 1, 2 and 3. In this case, I think it does have positive to the switch. So positive comes to the center one, the battery, and then the other 2 pins are going off to the 2 relays. So this is what this switch is going to replace. When this switch is off, no current is flowing through this magnet, so the relay is in its unenergized or non-energized position. What's changed since you last saw this too is we went from 4-pin relay to a 5-pin relay. And what that means is this switch, instead of just being off and then on, it actually swaps between 2 positions, 2 pins out. So in this case, when the switch is off, this pin is connected to this pin, and when the magnet gets energized, this pin is connected to this pin. So it's always connected to one or the other. It just depends whether it's in this energized state or non-energized state. So in the non-energized state, it's connected to this pin. And what that means is that the negative side of the battery is connected to the blue wire, and then when we turn the switch this way towards this relay, power flows, this switch flips, and suddenly positive power from the battery comes through the blue wire. Okay? The same thing happens on this side. If this switch, same switch is off, this magnet's not energized, this switch is down, so negative comes through this green wire to here. So when this switch is off, the green wire is connected to ground, and the blue wire is connected to ground, and the motor's going nowhere. What happens when we flick this switch up here? So we flick the switch, and suddenly Earth's connected to here. Power flows to the positive side of the battery. This magnet gets energized, this switch comes up. Positive power comes through here to the blue wire. The negative's not energized, and it stays on Earth. The motor turns in one direction. If we then flick our switch over to this side, this one gets de-energized, and this drops from positive back to Earth. This one gets energized, this switch flips up to positive, then we have positive coming to the green wire, and the negative going to Earth. And that's where we go from both sides being negative, blue positive, green negative, swapping it over, green positive, blue negative. And that's what gives you off, clockwise and anti-clockwise. It's now a few days later, and those of you who watched my last video will know that I stopped making this one because I ended up buying the wrong relays. The one I grabbed was this one, which was 12 volt, 40 amp, 5-pin. But you'll see up in the corner there, it says standard. And the big clue really on the back is it doesn't have an 87A pin listed. It actually has 2 87s. Whereas the one I needed, rather than being listed as a standard, Nava at least lists them as a changeover relay. And on the back you'll see it's got a pin 87 and a pin 87A, which is listed as a normally closed circuit. And that's the one I need to hook the earths up to. If we look at the diagram again briefly, we'll see this 87A. This is the circuit that we had permanently connected to the negative of the battery. And then when it says it's normally closed on the packet, what it means is this pin 30 is a closed circuit, a connected circuit with 87A in a normal state when the solenoid here or the relay is actually not energized. To make this wiring a little bit easier, I've made up a few little wiring looms and I'll talk you through those now. The first one is for this switch. So we've got our 3-position switch here, 3 wires, one goes to pin 86 on one relay, one goes to pin 86 on the other relay, and the other goes to earth. So I've got my 3-position switch and 3 wires on the end, the 1, 2, 3 here. Now what we also need is power from our battery going to pin 87 and 85 on both relays. So what I've got here is just a ring connector with 4 cores all bound together, and then 2 sets, so power going to 2 pins on one relay, power going to two pins on the other relay. Then here we've got some earth here, so from the negative of the battery we go to 87A on one relay, 87A on the other relay, and then up to the center of our switch. So this is going to be our negative, and then we got 1 wire to the switch and then 1 to each relay. So that's our negatives. And then finally here, this is an old wire from a trim tilt motor. I've got 2 spade connectors at one end, so we can have the blue wire going to pin 30 on one relay and the green wire going to pin 30 on the other relay, and then these 2 go to the trim tilt motor itself. Let's start wiring this whole thing up now. What I'm going to do is start with the 3-position switch, and from the diagram you can see that we need the center pin to go to the negative of the battery. So what I'm going to do is take this negative battery wiring harness I made up. It's got 3 tails on it. So one of them I'm going to take to the center pin of the switch, and that way the center pin of the switch will be able to take battery ground and direct it to either of these 2 wires here. Now these 2 wires are designed to go to pin 86 of our relays, each relay. So I'm going to put one on pin 86 of one relay and the other one to pin 86 of the other relay. Now pin 86 is our activation pin. Current has to flow from pin 86 to pin 85 on one, or pin 86 to pin 85 on the other, in order to activate the relay. But in order for that to happen, we need positives on the other side. So now I'm going to grab my positive wiring harness, which will go to the battery, and I'm going to put positive power on one side, and then here I'm going to take another set and put positive power on the other side. And by the other side I mean these 2 pins are paired, they're both sides of that electromagnetic coil. So when current flows from negative, the switch, to positive, the battery here, it'll activate each relay. So now with this circuit set up, if I was to hook these up to a battery, when I switch this switch, I'd hear each of the relays activating, even though there's nothing connected to them. And the reason for that is that power comes down this positive lead, goes to pin 86, could potentially flow through the coil up to the switch here, but when it gets to the switch there's no path to ground, and it's only till this switch is flicked that we now get a path to ground one way or a path to ground the other way. So what happens with these remaining pins is this one here is pin 30 and it goes to the trim tilt motor. So one pin 30 is going to the blue wire, one pin 30 is going to the green wire. So they're going to the 2 sides of the trim tilt motor. What current goes to pin 30 depends on what state each relay is in. If the relay is not energized, whatever's connected here to pin 87A will go to 30, and as soon as it's energized, this will be disconnected and this one here will be connected. So what we're going to do is put positive power to this one and negative power to this one, and that's what allows us to switch between positive and negative and turn the motor two different directions. This is my positive harness here, so I know what I've got here is just more positive power because I made 4 tails on that. So I'm putting one here and one here, and then on this negative harness I had, I've got one negative going to my switch, then I'm going to put another one to pin 87A on one relay, and the last one to pin 87A on the other one. Alright, so all that's left now is the trim tilt motor itself. And all I'm going to do there is go to pin 30 and put the blue wire for one, and I'm going to put the green wire onto pin 30 of the other. And that's the circuit complete. So what we can do now is hook positive and negative up to a battery source, put our multimeter on this blue and green, and then put our switch in different positions and see what we get. So what I'm going to do is set this multimeter to volts, connect one lead to the blue wire and one to the green. So these are the ends that would actually go to the trim tilt motor itself. Now my switch is in the center position. What that means is current can't flow between pins 85 and 86 on either relay, which means both relays are sending battery ground to these blue and green wires. So what we end up with is a reading of 0 volts. If I then send ground to the black wire, it means that that relay gets activated, and we can see there we've got positive 12 volts. If I go back to the middle, that relay deactivates, we get 0 volts. If I go the other way, you can now see we've got negative 12 volts. So that shows how this circuit, with a couple of cheap relays and one 3-position switch, can do the job that these trim tilt relays do. There's a few improvements we can make. You can buy little sockets for these relays to try and keep the wiring a little bit neater as such. And we could also go to this momentary switch, which is a bit more in the style of a traditional boat switch for trim tilt. We could certainly find a more waterproof switch for this, and we could certainly find more waterproof relays. But what I'm going to do now is I'm going to mount them all up into a bit of a plastic box, and then we'll take it out to the boat and use it to control the actual trim tilt motor. Alright, I'll admit none of it's very pretty, and it's not very waterproof at all, but you get the idea. So now, I've simply got, coming out of my box, the switch, wires to my trim tilt motor, and wires to my battery. So it's pretty simple to connect once we get to this stage. So let's take it on the boat and see how it goes. The first thing I do is just hook up these positive and negative leads straight to the battery on this boat, and then we'll disconnect the starter motor from the existing trim tilt relay and hook it up to this directly. I'll show you a close up that when we get to there. So here I've got a little relay set just straight to the battery. Now what I'm going to do, this is the existing sort of bespoke Yamaha trim tilt unit. So technically it's one unit, but really it's a very similar circuit inside. So this is the green wire and the blue wire going down to the trim tilt motor. I'll disconnect these two from these top left and bottom right terminals on the trim tilt relay here. I'll pull them through and we'll connect them up with our relay. Disconnected now, I'm just going to pull them through the grommet. So these now are the two blue and green wires that go straight down to the trim tilt motor. And all I'm going to do now is connect blue to blue, green to green with our relay setup. So I've just used a couple of bolts and nuts just to connect these two together, and we're ready for the test. I've actually never made one of these before. It's all a bit theoretical for me, so
Here's the drum roll. Oh, that's down, off, and up. The battery in this outboard's getting a bit flat. Success. So I'm kind of quietly pleased that actually worked. So why would you build one of these? Good question. The main reason I did is because I had a question from a viewer about how do you control the trim tilt on a boat? Can I just put a switch on it? I've got a trim tilt, I don't have the relay, the electronics. So the answer is yes, but not simply, mostly because of the current that has to pass through the switches. But it's not that tricky to make one of these, as you've seen. With regards to waterproofing, you can get more waterproof boxes than this one. You get the ones that sort of have a bit of an O-ring seal around them and latches, and once you've got your wires come through, you can actually sort of put an epoxy or some sort of resin on those and it'll seal them pretty well. Then you can also get those rubber boots that go over the switch to make that a bit more waterproof as well. So you can do a pretty good job with this control unit. How it compares cost-wise to buying an original manufacturer one for your outboard, should your trim tilt relay fail? I don't know, by the time you put the effort in, but it's kind of a fun project, and I think by building something like this, you really do start to understand how they work. And I think understanding how they work always helps you diagnose them should you have a problem with the factory unit anyway. All right, well, the sun's about to set, so I'll wrap it up here. I hope you enjoyed. I hope you got something out of this video, and if you did, please rate, comment, and subscribe, and I'll catch you next time. See ya.